Hi student, this is Dr. Mahantesh, uh, Assistant Professor of Mathematics, Government College, Gulbarga. I'm handling your practical sessions uh, of the first BSc. So today I will discuss about the first and second lab work that is based on the chapter sequences. Already the sequence chapter has been started in your online teaching. Once again I will briefly brief it, and next I will go to the lab components. Okay, let me discuss what is meant by the sequences. What are sequences? The definition is that a sequence is a function f from n to r. A function f from n to r is said to be a sequence if the domain of the function is set of natural numbers and the range is set of real numbers. So what is the set of natural numbers? Set of natural number except 0, all the positive numbers are the set of the elements of the natural number set. Similarly, real numbers, so real numbers is a set of union of rational numbers and irrational number. What is rational number? Any number which is written in the form of p by q, where q is not equal to 0, is called as rational number. Suppose it is in the form of the square root or a cube root, that values are called as irrational numbers. So both values, suppose they stayed in a set, then that set is said to be set of real numbers. Here sequence is a function from set of natural numbers to set of real numbers. And if f is a function from natural number set to real number set, then the set of natural number is the domain and the range is set of real numbers. For example, suppose I take, and sequences are represented by the flower brackets xn means it has an elements up to n elements, n equal to 1 2 3 4. This time see this picture. So this first circle is domain and second circle is range. When I substitute x equals to, what is xn? Xn is 2n. I will substitute n value should be set from the set of natural numbers. Therefore here I am substituting n equals to 1, then the range will be 2, and I will substitute n equal to 2. 2 into 2 is equals to 4. I will substitute 3, it will be 6. See, when I substitute the natural numbers, I will get the real numbers that are 2 4 6. So this is a set of even numbers, and this is called a sequence. It is the sequence. How the sequence is, already we studied this sequence in 10th class also. 10th ಅಲ್ಲಿ ಓದಿದ್ದೀವಿ ನಾವು ಸೀಕ್ವೆನ್ಸಸ್, ಶ್ರೇಣಿಗಳು ಮತ್ತು ಶ್ರೇಣಿಗಳು ಅಂತ. ಸೊ ಶ್ರೇಣಿ ಅಂದರೆ ಸೀಕ್ವೆನ್ಸು, ಶ್ರೇಣಿ ಅಂದರೆ ಸೀರೀಸ್, ರೈಟ್. ಸೊ ಅದೇ ರೀತಿ ಇಲ್ಲಿ ಈ ನ್ಯಾಚುರಲ್ ನಂಬರ್, ಸ್ವಾಭಾವಿಕ ಸಂಖ್ಯೆಗಳನ್ನು ಈ 2n ನಲ್ಲಿ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿದಾಗ ನಮಗೆ ಸಿಗೋದು ಯಾವುದು? ರಿಯಲ್ ನಂಬರ್ ಸೆಟ್ ಸಿಗುತ್ತೆ. ಇದು 2 2 4 6, ಈ 6 8 10, ಇಟ್ ಈಸ್ ಇನ್ಫೈನೈಟ್ ಸೆಟ್. ಸೊ ದಿಸ್ ಈಸ್ ಕಾಲ್ಡ್ ಆಸ್ ಅ ಸೀಕ್ವೆನ್ಸ್. So sequence is a function from natural number to real numbers. Okay, the first set is always called as domain. This is also called as codomain, or it is called as a range. So example for the sequence is, see here, example for the sequence. So sequences are represented by flower bracket and xn and 1 by n. Substitute n equal to natural number, n equal to 1 1, n equal to 2 1 by 2, n equal to 3 1 by 3. So all the numbers small n should be from the set of natural number. This is one sequence, and this is another sequence, 1 by n plus 1. See, these are all infinite sequences. Some sequences are infinite and some sequences are finite, right? So this is also one of the example for that. And xn equals to n plus 1. This is also an example for the sequence. So n plus 1 is 1, 1 plus 1 is 2, 1 plus 2 is 3. Like that the sequence goes on. So this is also a sequence. So 1 to power n is the sequence. Suppose I substitute n equal to 1, I will get 1, n equal to 2, I will get 1, n equal to 3, I will get 1. So I am getting the same numbers or the same sequence elements in this set. Therefore this is called as a constant sequence. If we are getting even substituting now natural number 1 2 3 substitute ಮಾಡಿದಾಗಲೂ ಕೂಡ suppose we get the same number in the range, ಆವಾಗ ನಾವು ಅದಕ್ಕೆ ಏನು ಹೇಳ್ತೀವಿ, ಸೆಟ್ ಆಫ್ ನ್ಯಾಚುರಲ್ ನಂಬರ್ಸ್ ಹಾಕಿದಾಗ ಬರುವಂತಹ ರೇಂಜ್ ಎಲಿಮೆಂಟ್ಸು ಕಾನ್ಸ್ಟಂಟ್ ಆಗಿದ್ದರೆ ದಟ್ ಸೀಕ್ವೆನ್ಸ್ ಈಸ್ ಕಾಲ್ಡ್ ಆಸ್ ಕಾನ್ಸ್ಟಂಟ್ ಸೀಕ್ವೆನ್ಸ್. Suppose this is another exam, x to power xn is equals to minus 1 to power n. Substitute 1 ಮಾಡಿದಾಗ minus 1 ಬರುತ್ತೆ, 2 ಮಾಡಿದಾಗ plus 1 ಬರುತ್ತೆ, ಮತ್ತೆ 3 ಮಾಡಿದಾಗ minus 1 ಬರುತ್ತೆ, 4 ಮಾಡಿದಾಗ plus 1 ಬರುತ್ತೆ. So I am getting alternative plus 1 minus 1 plus 1 minus 1. Such sequences are called as oscillatory sequences. We are getting same repeated values in the range. Therefore ಇದಕ್ಕೆ ಏನಂತೀವಿ ನಾವು oscillatory sequence ಅಂತ ಹೇಳ್ತೀವಿ. This is called as oscillatory sequence. Now bounded sequence. What is bounded sequence? Suppose a sequence is bounded below and bounded above, then such sequences are called as bounded sequence. See, suppose I consider these two, so then it is called as small m is less than or equal to xn. Xn is a sequence, the m is a real number, so these two when we consider it is called as bounded below. Suppose I consider these two, then it is called as bounded above. If a sequence is bounded below and bounded above, then such sequences are called as bounded sequences. ಅದಕ್ಕೆ ನಾವೇನು ಹೇಳ್ತೀವಿ, bounded sequence ಅಂತ ಹೇಳ್ತೀವಿ. ಸ್ಮಾಲ್ m ಗೆ ನಾವು GLB ಅಂತ ಹೇಳ್ತೀವಿ, ಕ್ಯಾಪಿಟಲ್ m ಗೆ ನಾವು LUB ಅಂತ ಹೇಳ್ತೀವಿ. ಯಾಕೆ ಹೇಳ್ತೀವಿ ಅಂತಂದ್ರೆ why we are calling that them, just I will explain with an example here. So a sequence xn, x 1 by n ಇದೆ, 1 ಹಾಕಿದಾಗ 1 ಬಂತು, 2 ಹಾಕಿದಾಗ 1 by 2 ಬಂತು, 3 ಹಾಕಿದಾಗ 1 by 3 ಬಂತು. So this is sequence. Suppose I write these values in form of this. So xn ಇಲ್ಲೇನಿದೆ, ಇದಕ್ಕಿಂತ ಈಚೆ ಏನಿದೆ 0 minus 1 minus 2. So ಇದು 0 ಕಿಂತ ಮೇಲೆ ಇದೆ. These elements are all more than 0 and next ಏನಿದೆ 1 2 1.5 like that it is there. So this, suppose this is a set of sequence values. See, this xn has more than 0 and less than 1. So among this is one lower bound, this is one lower bound, this is one lower bound. 0 minus 1 minus 2 are the lower bounds. Among these lower bounds, which is bigger, which is greater? 0 is a greater, therefore it is called as greatest least bond or greater least bond ಅಂತ ಹೇಳ್ತೀವಿ, right? This is a GLB. So among these are all upper bounds. 1 is upper bound, 2 is upper bound, 3 is upper bound. So 1 is called as least upper bound. Among these all upper bonds, 1 is a least, therefore it is called as least upper bond, that is called as LUP. Supremum ಮತ್ತೆ infimum ಅಂತ ಹೇಳ್ತೀವಿ. This is called supremum and infimum. Let me come to the limit of a sequence. Limit of sequence ಅಂದ್ರೆ ಏನು? Already we have studied the limit of sequence. Limit ಅಂತ ಓದಿದ್ದೀವಿ ನಾವು. ಫಾರ್ ಎಕ್ಸಾಂಪಲ್, ಲಿಮಿಟ್ ಆಸ್ x ಟೆಂಡ್ಸ್ ಟು 1, x ಪ್ಲಸ್ 1 ಇತ್ತು ಅಂದರೆ x ವ್ಯಾಲ್ಯೂ ಅಲ್ಲಿ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿದಾಗ ಏನು ಬರುತ್ತೆ, ಅದು ಲಿಮಿಟ್ ಆಫ್ ಅ ಸೀಕ್ವೆನ್ಸ್. ಅದು ಲಿಮಿಟ್ ಅಂತ ಹೇಳ್ತೀವಿ, ಲಿಮಿಟ್ ಆಫ್ ಫಂಕ್ಷನ್ ಅಂತ ಹೇಳ್ತೀವಿ. ಹಿಯರ್ ವಿ ಆರ್ ಕ್ಯಾಲ್ಕುಲೇಟಿಂಗ್ ವಾಟ್ ಈಸ್ ಲಿಮಿಟ್ ಆಫ್ ಅ ಸೀಕ್ವೆನ್ಸ್. ಸಿ ಹಿಯರ್, for any sequence xn, L is L, this is a small l, L is said to be a limit of sequence as n tends to infinity. For given epsilon greater than 0, small m belongs to capital M, such that xn minus L, mod of xn minus L less than epsilon. Epsilon is a small parameter. Now when we substitute a limit of a sequence ಅಲ್ಲಿ limit value substitute ಮಾಡಿದಾಗ the sequence value ಮತ್ತು limit value should be less than epsilon. ಅಂದರೆ ಅವು ಎರಡು ಈಕ್ವಲ್ ಆಗಿರಬೇಕು. Suppose I take this L this side, that will become what? That will become limit as n tends to infinity xn is equals to L. This is a finite value. So this is called as limit of sequence. ನಮಗೆ ಗೊತ್ತು what is the limit of function ಅಂತಂದರೆ, ಈಗ suppose function is x plus 2 ಅಂತಿತ್ತು. Suppose ನಾನು x tends to 2 ಇದ್ದಾಗ what is the function value? X plus 2. X substitute the value of x is 2. 2 plus 2 equal to 4. In the similar way we find the limit of sequence. Okay. Now A small example is given here. Find the, if xn equals to 1 by n, find the limit of sequence. See here. So limit as n tends to infinity, xn. What is xn? Xn is 1 by n. N equals to what I have to substitute? Infinity I have to substitute. So that value is equals to 0. 0 is a finite value, therefore it is the limit of the given sequence 1 by n. Similarly, I will go for one more example of convergent. The next concept is convergent. See, what is convergent sequence? Convergent sequence ಅಂದ್ರೆ ಏನು? ಸೊ ಯಾವುದಾದ್ರೂ ಸೀಕ್ವೆನ್ಸಿಗೆ ನಾವು ಲಿಮಿಟ್ ಕಂಡು ಹಿಡಿದಾಗ, ಲಿಮಿಟ್ ಆಫ್ ಎ ಸೀಕ್ವೆನ್ಸ್ ಇಫ್ ಇಟ್ ಬಿಕಮ್ ಯುನಿಕ್ ಆರ್ ಅನ್ಚೇಂಜ್ಡ್ ಫೈನೈಟ್, ನಮಗೆ ಲಿಮಿಟ್ ಬಂತು ಅಂದರೆ ಆ ಸೀಕ್ವೆನ್ಸಿಗೆ ನಾವು ಫೈನೈಟ್ ಸೀಕ್ವೆನ್ಸ್ ಅಥವಾ ಕನ್ವರ್ಜೆಂಟ್ ಸೀಕ್ವೆನ್ಸ್ ಅಂತ ಹೇಳ್ತೀವಿ. ಸಿ ಹಿಯರ್ ದ ಡೆಫಿನಿಷನ್ ಇಸ್ ದ್ಯಾಟ್ ಅ ಸೀಕ್ವೆನ್ಸ್ xn is said to be convergent if limit of a sequence tends to finite quantity or unique quantity, say as capital L, as n tends to infinity. So ಯಾವುದೇ ಸೀಕ್ವೆನ್ಸ್ ನಾವು ಲಿಮಿಟ್ ಕಂಡುಹಿಡಿದಾಗ, ಸಪೋಸ್ ವಿ ಗೆಟ್ the limit value as finite or unchanged, then we say that that sequence is convergent. The sequence is said to be convergent. Let me take one example for that. Okay, this is an example for that. See, xn equals to 2n plus 3, 3n plus 4, 1 divided by, this is a fractional sequence. Verify, is it a convergent sequence? Yes. Take the sequence and we suppose I substitute n equal to infinity here only, it will also become infinity, it will also become infinity. Therefore what we have to do, we have to take n outside. So suppose I take n outside, 2 plus 3 by n will remain here. Again suppose I take in the denominator n outside, 3 plus 4 by n will come, and this n will get cancelled. Remaining thing is what? 2 plus n by 3 by n, 3 plus 4 by n. So now check it out. The 2 is as it is, I have written. 3 is also as it is. 3 by n, n equal to infinity, any number by infinity, that value is equals to 0. Here also it's 0, therefore its value is 2 by 3. So limit of the sequence is 2 by 3. Hence it is a finite value and unique quantity. Therefore the given sequence xn is a convergent sequence. Now we'll go for the divergent sequence. What is divergent sequence? Suppose the limit of given sequence is plus infinity or minus infinity, then such sequences are called as divergent sequences. See here, a sequence xn is said to be divergent if its limit value tends to infinity as n tends to infinity, or limit of xn as n tends to infinity may be plus infinity, may be negative infinity. Suppose these are the values of limit of any sequence, then that sequences are called as divergent sequence. ಅದನ್ನು ನಾವು divergent sequence ಅಂತ ಹೇಳ್ತೀವಿ. Example, xn is equals to 2n and limit, applying the limit n tends to infinity xn, so that will become 2n. The value is equals to 2 infinity, this is positive infinity. So the limit value of a sequence xn equals to 2n is plus infinity. Hence this is a divergent sequence. Similarly, another sequence is there, oscillatory sequence. If the limit is not unique, suppose we apply limit of a sequence as n tends to infinity. Suppose we are not getting any finite value, or we are not getting any plus infinity or negative infinity, we get some other value which are not constant, unique. It is not unique, it is altering. Such sequences are said to be oscillatory sequences. Now xn is equals to minus 1 to power n. This is one example for oscillatory sequence. Substitute n equal to 1 infinity minus infinity. So suppose I substitute 1, it will be minus 1. Suppose I substitute 2, it will be plus 1. So I am getting only minus 1 or plus 1. So the limit of this sequence is not finite, therefore it is oscillatory sequence. It is called as oscillatory sequence. Okay, on this topic we have to cover the first and second lab programs of your syllabus. So it is being to be conducted in the Maxima software. So whenever you know something about that, now I will give a brief explanation about the Maxima commands which are we are going to use in the programming language Maxima. So plus symbol is used for addition, as usual you know. Minus symbol is used for the subtraction, and the star symbol is used for the multiplication, and backslash symbol is used for the division, and this cap is used for denoting the power. And any, suppose any values are assigning to some unknown or variable, then I will use this colon. And equal symbol is used in some conditions. Suppose I am using if, while, do while, such conditions. When I am conditional statements I am using, then I have to use the equal symbol. So whenever we are using if statement, then first we have to use if, then we have to use print. Then again another form of using the if, then print, afterwards if print, or it will come in this sequence: if, else if, then print else, like this. So it will come in this sequence. Suppose we are using the if else statements, so it is in this sequence format we have to use. First if we have to use, suppose a condition is given here, then we have to print, writing, then we have to print what is that value. Else, suppose that condition is not satisfied, then we have to write else and print what we need. This is for only two conditions. When there are three conditions, first we have to if, then print, then else, again if, then print, again else. So this sequence we have to maintain in doing the program with if else condition. Suppose we want to print any result or any command lines, then we have to use this statement print in bracket inverted, between the inverted comma we have to print whatever we want to print, and afterwards we have to give this dollar symbol. If in if statement, then we are printing, no, there we should not give the dollar symbol. This is the final result where we are printing, there we have to give, or some command some comment lines or some information lines, suppose we are printing, then also we can give this dollar symbol. And before starting any program, we have to use kill all dollar symbol, which clears all the earlier computations. Suppose we have done any computation in that page and erased, that will be stored in the data, their memory. So suppose we use this command, that will be erased, and it will be connected with only the new readings what we are doing. As well as infinity symbol, I can use a symbol, or I can write simply INF. So it gives the meaning of infinity. We are using the infinity in the programming. I can use the symbol, or I can write INF. As well as ind means indefinite or oscillatory value. So this is a symbol to use in the programming. Suppose I write ind, that means it is an indefinite or oscillatory value. Next, limit, to find the limit. Suppose I write a command limit, that is what it does the work of computing the limit. So how we are writing that? We have to write limit, in a bracket write the expression for which we are going to find the limit, and for which value it is tending. So this we have to use in this fashion. Okay, xn, suppose I am taking the sequence, write the sequence as n tends to infinity, so that can be written as limit xn comma n comma infinity. In the programming, suppose we find this symbol I%1, that is the first input what we are typing, that first line, first input will be given in this format, and suppose we execute that we get O%1. O means output, first output. Okay, and the execution of the Maxima program can be done by pressing the shift enter. After typing the line, by pressing shift enter, we can execute this program. Okay, let me give which type of program we are going to do here. Maxima program. First, test the convergence of a sequence. In that example, examine the convergence of the sequence xn equals to n square minus 4 n minus 2. Here just we have to find the solution manually. Suppose we know manual solution, then we can cross check with the programming. See, limit as n tends to infinity xn, limit as n tends to infinity, this n square minus 4 is nothing but n square minus 2 square, a square minus b square. So n plus 2, n minus 2, and denominator is as n minus 2. Why I am splitting this? Suppose I substitute n equal to infinity here only, I am getting the infinity by infinity, so that is nothing but indeterminate form, so we cannot find the limit of the given sequence. So these two, n minus 2 will get cancelled, only n plus 2 remained, and substitute the value of n is equals to infinity, and infinity plus anything will be infinity. Therefore the given sequence is not convergent, it is divergent. The limit of the given sequence is plus infinity, therefore it is divergent. Second example, what we are doing in the programming is examining the convergence of xn to n equals to xn equals to 2n plus 3 divided by 4n plus 5. So as usual, solution will be limit n tends to infinity xn, limit as n tends to infinity 2n plus 3 divided by 4n plus 5. Again take n outside, here also in the numerator, here also in the denominator. So this will become like this, n will get cancelled, so only remain 2 plus 3 by n, 4 plus 5 by n, and now substitute the limit as n tends to infinity. 2 is as it is, 4 is as it is, 3 by infinity is 0, as well as 5 by infinity the value is 0. So this is 2 by 4, 2 by 4 is nothing but 1 by 2, which is unique. Therefore this given sequence xn is convergent. And the third example what we are doing in the Maxima program is this: examine the convergent of xn equals to minus 1 to power n. Similarly, just you substitute limit n tends to infinity xn, limit n tends to infinity minus 1 to power n, xn is equals to minus 1 to power n. So minus 1 or plus 1 we get the value, so it is indefinite. Therefore the given sequence is oscillatory. The given sequence is oscillatory. So these problems we are carrying out in the next video. Therefore you please carefully read this, watch this video, and please note these 3 examples. So in the next video I am going to show you how to execute these 3 problems using the Maxima softwares. And if please subscribe this channel and share to your friends, so that you will get the next video notification to you people. Thank you very much. In the next video we are seeing how to execute these 3 examples in the Maxima software.